Making sure, yeah, it's recording. Okay, does anybody have a question from 7.1? Let's say 1 through 15 before the word problems. Do you have any trouble with 1 through 15? Good on those? All right, I only gave you 17, 19, 21, 23, 4 word problems. Did you have trouble with any of those?
Can you do 19, please?
And it's almost always the drawing. If you can get the drawing set up, and I'm trying not to look at the drawing that they give me in the book. I can't remember if the problems that I gave you on the practice test and test had the drawing or not, but you need to practice coming up with the drawing yourself because that's really the hard part. Number 19 says, a cable car carries passengers from point A to point B, which is 1.2 miles from, no, I'm sorry. Cable car carries passengers from point A, which is 1.2 miles from a point B at the base of the mountain. So I need a mountain, and I need a point B at the base of the mountain, and I need a cable car carrying people from some point A up to the top of the mountain. And let's see, cable car carries passengers from point A, which is 1.2 miles from point B, at the base of a mountain to a point P at the top of the mountain. Now, Miss Kelsey, did your picture look like that so far?
Yes.
Okay. The angles of elevation of P from A and B are 21 degrees and 65 degrees respectively. Now remember, angles of elevation always mean with respect to the horizontal. So a person standing at A and looking up at P would have their neck craned at a 21-degree angle. Now, I drew this looking like it was a right triangle because all my triangles basically look the same. But if they're telling me the angle of elevation at B is 65 degrees, that's, again, with respect to the horizontal. And if that's not 90 degrees, that's not supposed to look like a right triangle. So my pictures are just way off. But let's, I mean, that doesn't matter as much as the fact that I get the angles labeled properly. It doesn't really matter if they look like a 65-degree angle or not. So did your picture look like that, Miss Kelsey?
Yes.
Okay, good. The A part says approximate the distance between A and P. If we call that eeny, meeny, miny, mo, D for distance works well, or X, doesn't matter. Then do I have enough to solve for D using the law of sines? Do I have one side and an angle opposite it? Well, the only side I know is this, and I don't have the angle opposite it. So I'm either going to have to be able to find this angle. I'll just call it theta. I'll either have to be able to find theta, or I'll have to use some other law because I don't have the requirements for the law of sines. Can I find theta, or am I going to have to invent the law of cosines early?
You can find it.
Sure. If you're given 2 of the angles in the triangle, then the third angle is 180 minus the 2 that you're given. And so theta is, let's see, that's 86 from 180 is 94. Is that right? Ah, that's the one that's supposed to look like a right angle. Did I subtract correctly? 89, no, 86, 90, yes, 180. So theta is 94. Now that I know theta and I know the side opposite theta, I'm ready for the law of sines. And if I'm looking for D, then I need to say sides in the numerator. I don't have to do it, but it makes the solving the equation easier if I put what I'm looking for in the numerator, sine of the angle opposite it, has to be the other side that I'm given, and sine of the angle opposite it, the angle opposite, wait, D over sine of 65 equals 1.2 over the sine of theta, and we found theta to be 94 degrees. That would give us the answer to the A part. Now, Miss Kelsey, did you get the A part and just had trouble with the B part? Or no, I couldn't get the A part?
Yeah, I got the A part. I just had trouble with the B part.
Okay, well, let's call H the height of the mountain and say, how would I find H? What did the A part come out to be to the nearest, let's just say, mile, a tenth of a mile, because this is a tenth of a mile. What did the A part come out to be, Kelsey?
I don't have my answers on me right now. And my
Don't worry about it. I don't think we're going to have that to do the B part. Could I find H using the law of sines as well?
Yes.
Yeah, because I have the same complete ratio. I have 1.2 over sine of 94 degrees, and I would just need to say H over the sine of the angle opposite it equals that same ratio. You know what? Let me double check one thing. Yeah, that would still be right. I was thinking, does it matter that my picture's not drawn to scale? The actual picture would look more like this is 21 degrees and 65 degrees. Can I draw an angle that looks like 65 degrees? Yeah, maybe that. But this would still be D, and that would still be H, and H is still the angle opposite 21 degrees.
Mm-hmm.
Does that make sense, Miss Kelsey?
Yes.
Okay. All right. Practice drawing the picture. Did you have any problem with 17, 21, or 23?
I feel pretty good on those.
Okay. Good, good, good. Well, the last thing I get to teach you in pre-calculus, and then I hope and pray that I see you in person this fall. The last thing that I get to teach you this semester is the law of cosines. And again, the whole purpose of the law of sines and law of cosines is to be able to find missing parts of a triangle using trig, but not just with right triangles, with any triangle, obtuse triangles. If we have that one complete ratio of an angle and a side opposite it, then we can use the law of sines. But what if we don't have that? Well, everything that's not covered by the law of sines is covered by the law of cosines. And for just a minute, you can panic when you see, zoom in on those just a little bit. When you see, y'all know me in mirror images. There we go. You are not going to memorize these three formulas to find A, B, or C. You're going to say this general form to yourself 2 or 3 times, and you're totally going to have it. You'll have it by the time we work these examples. The general form of the law of cosines says the square of the length of any side of a triangle. Well, a side of a triangle is either A, B, or C. So this first phrase is giving me A squared or B squared or C squared. And let's just talk about if we're looking for A. Then the square of the length of A equals the sum of the squares of the length of the other 2 sides. Well, if we're looking for A, then the other 2 sides are B and C. So the sum of the squares of the lengths of the other 2 sides would be B squared plus C squared minus twice the product, 2 times the length of the other 2 sides, 2 times B times C, and cosine of the angle between them. Well, the angle between B and C would be alpha. And what you can do to help you memorize this, if you have A squared on the left, you're going to have cosine alpha on the right. If you have B squared on the left, you're going to have cosine beta on the right. If you have C squared on the left, you're going to have cosine gamma on the right. I did start recording this, didn't I? Please say yes. Yes, okay. So we're not going to sit down and memorize that. We're going to say these words on 2 or 3 problems, and then it'll just be stuck in our head all summer. You're just going to swim all summer saying these words to yourself, I'm sure. The law of cosines is used to determine the missing parts of an oblique triangle. And you know what? I've been saying obtuse. That's wrong. That's very obtuse of me. An angle that's not a right triangle is an oblique triangle, not an obtuse triangle. Anytime you can't use the law of sines. So you can't use the law of sines when you're given 2 sides and the angle between them, or when you're given 3 sides. Now, when you're given 2 sides and the angle between them, the reason this note exists, the reason you want to find the angle opposite the shortest side, that will help you avoid that ambiguous case with the law of sines. Remember this ambiguous case where could be no triangle, could be 2 triangles, could be 1 triangle. If we find the angle opposite the shortest side, that has to be the smallest angle. The smallest angle is an acute angle. Every triangle's got to have at least 1 acute angle. And if we find it first, then we don't run into that could be 1, could be 2, could be none situation. We're trying to avoid that ambiguous case. So let's look at number 10, see what we're given. Number 10 says alpha is 23 degrees 40 minutes, and C is 4.3, and we don't know the units. It's 4.30. B is 70.0. I don't know why they didn't give us the same number of significant digits on both of those, but I'm not worried about it. All right, if the only angle I'm given is alpha, then what side do I have to be given in order to use the law of sines?
A.
I'd have to know A and alpha to use the law of sines. So I can't use the law of sines. Got to use the law of cosines. And I want to find the angle opposite the shortest side first, so that I don't run into that ambiguous case when I use the law of sines to finish up the problem in a minute. What's the shortest side of this triangle?
C.
Yeah. So if that's my shortest side, what's the angle that I'm going to be looking for to begin with? The angle opposite C would be
Is it gamma?
gamma, right? So if I'm looking for gamma, then, hold on just a second. If I'm looking for gamma, then I need cosine gamma on the right-hand side, and that means the left-hand side is going to start with the side opposite gamma, and the side opposite gamma is C. So I'm about to say all these words to myself. Because I'm looking for gamma, I'm going to start with the side opposite gamma squared equals the sum of the square of the other two sides. 4.3 squared plus 70 squared minus twice the product of the other two sides cosine of the angle between them. What have I just done? Jeez Louise. Okay. I'm a knucklehead. I'm a complete knucklehead, and I'm sorry. If the only angle I know is alpha, then alpha's what's going to have to be right here, because I don't know any other angle I can take the cosine of. Geez Louise. Gamma is what I'm looking for. I was thinking I had to know this angle. I don't have to know that angle. That's the angle I'm looking for. All right. I completely screwed that up in my head. But let's look at those words one more time. Let me go back through what I just bungled and say that if I'm looking for the angle opposite the shortest side is C, the angle opposite C is gamma. If I want cosine gamma, because I'm looking for gamma, if I want cosine gamma on the right, I have to start with C on the left. So C squared equals the sum of the squares of the other two sides. Geez. This is not right, because the other two sides would be A and B, and I don't have A and B. Just gonna have to erase that and play like it didn't happen. I'm so sorry. All right. Let's cut that out of the video and say that if I'm given alpha, then I can find A using the law of cosines, because when I use these words to put this into an equation, if I have cosine alpha on the right, then I'm going to have A on the left, and A squared is going to be sum of the squares of the other two sides minus twice the product of the other two sides cosine of the angle between them. And the angle between them, if I have A on the left-hand side, then I'm going to have cosine alpha on the right-hand side. We'll apply this note in just a minute, find the angle opposite the shortest side. I have to find what the third side is before I know which is the shortest side. So that was not what I should have been thinking first. What I should have been thinking first is find the other side and then find the angle opposite the shortest side. If I'm given alpha and I want to use it on the right-hand side, I've got to start with A on the left-hand side. A squared equals B squared plus C squared minus 2BC cosine alpha. And if I'm solving for A, all I have to do is take the square root of both sides. So I'm not even going to write this down anymore. I'm going to go ahead and say A is the square root of all that, just so I don't have to copy it down again. And because I've already punched that on the calculator, I can tell you that A is approximately 66.1. So far, so good? Kelsey, Evan, and Carly? Does that make sense?
Yeah.
It's going to make more sense when we do another one that I don't mess up to begin with. But now that we know all three sides, 4.3, 66, and 70, we have A and alpha, we can use the law of sines. If I use the law of sines to find beta first, then I could get that ambiguous case. But if I use the law of sines to find gamma first, the angle opposite the shortest side has to be an acute angle, and that eliminates the ambiguous case. So use the law of sines to find gamma. And if I'm looking for an angle, I'm going to put the angles on top of each ratio. The sine of gamma over C equals the sine of alpha over A. When I multiply both sides by 4.3, I'm going to have sine of gamma equals some number between -1 and 1, and I'm going to take inverse sine of that number. To get gamma. And if alpha was given to me to the nearest 10 minutes, then I'm going to express gamma to the nearest 10 minutes. To the nearest 10 minutes, I got gamma is 1 degree 30 minutes. A tiny little angle because that's a tiny little side. Now we have 5 parts of our triangle. We have 2 of the angles and we have all 3 sides. So what's the only thing we're missing?
Beta.
Beta. And if we're working for NASA and we don't want to use anything we've approximated, then, excuse me, I would have to use this whole expression for sine of gamma, excuse me, for gamma. If we're not working for NASA, we can just say beta is 180 degrees minus alpha minus gamma. Working for NASA, again, you would not want to use an expression you've already rounded. You would put this whole expression in place of gamma instead of just the 1 degree 30 minutes. But if we're just working at McDonald's, this is going to be good enough. I got beta was 154 degrees and 50 minutes.
On the test, is it
Yes.
okay if we subtract it like that, or would you like us to get like the exact?
Let's play like we're working for McDonald's at this point in our lives.
Okay.
As long as you know that if you needed an exact answer, if you're conducting an atomic experiment or launching a rocket to Mars or sending a submarine to the Mariana Trench, then use the exact answer.
Mm-hmm.
But this is good enough for us. All right, so sounds like too difficult. I'm not even going to say difficult. 2 things we have to watch out for in 7.2. Number 1, just get these words in your head so that you can set up your equation correctly. And then number 2, make sure you can punch that on your calculator. Let's see the one other scenario where we could not use the law of sines. Number 12. If we're given 3 sides, then obviously we don't have the 1 complete ratio that we need for the law of sines. A is 3.7, B is 5.6, and C is 9.8. Play like I give you 3 sticks. One of them's 3.7 inches long, one of them's 5.6 inches long, one of them is 9.8 inches long. I want you to find the 3 angles that would result from putting these 3 sticks together in a triangle. Well, what do you think we need to find first? Given that we already know, here we had to use the law of cosines to find the 3rd side, but here we have all 3 sides. So what do you want to find first? Actually, I forgot to show you this second note. When you're given 3 sides, you want to find the largest angle first, because if you find the largest angle, that eliminates the ambiguous case in the law of sines. The largest angle has to be the angle opposite the longest side. And if you find that, then by the time you get to law of sines, you won't have the ambiguous case. So what's the angle opposite the longest side? What's the longest side?
C.
C. So the angle opposite the longest side would be gamma. Alpha is always the angle opposite A. Beta is always the angle opposite B. Gamma is always the angle opposite C, except for the problems in my math lab. Instead of using alpha, beta, gamma for the angles, they use capital A, capital B, capital C. Doesn't matter. All right, So if we want to find gamma, then we're going to have cosine gamma on the right-hand side. What does that mean we have to start with on the left-hand side?
The 9.8.
Yep, the C. If we have cosine gamma on the right, then our equation is going to start with C squared. And C squared equals the sum of the squares of the other two sides what's the words after that? Sum of the squares of the other two sides minus twice the product of the other two sides and the cosine of the angle between them. Now I do want to get cosine gamma by itself before I pick up my calculator. So if I wanted cosine gamma by itself, how would I solve that whole expression for cosine gamma? I don't want to pick up my calculator yet. How could I get this by itself?
Could you divide that, all that?
Well, think about this. If I had C squared equals A squared plus B squared minus 2AB, let's just say I'm solving that equation for X. I want the X by itself. What's the first thing I'd have to do to get the X by itself? I wouldn't divide by 2AB first. I'd do what?
You'd move everything that don't have an X in it to the other side.
Okay. And since move isn't an algebraic operation, what should you be saying instead of move? How do you move?
Inverse operations.
Well, what would you have to do to move that A squared over? Say subtract.
Subtract.
Yeah. I was trying to get you to say subtract instead of move, because if this had been minus B squared, then I'd have to add B squared to both sides. Move is not a mathematical operation. But since both of these are added, first I would subtract them. Just like here, I'd subtract the A squared and the B squared, and then I would divide by the negative 2AB. That would get me the cosine of gamma by itself. And if I don't want to write all this down again, and I just want to get gamma, what would I do to both sides to have gamma on the right-hand side instead of cosine gamma? If I have cosine gamma, how do I find gamma?
Inverse of cosine.
Beautiful. That's what you've got to punch on the calculator. Do all of this, hit equals, and then hit inverse cosine. Now, actually, let's see what that expression is. Gamma is the inverse cosine of, let's see what all that turns out to be. (9.8 squared minus 3.7 squared minus 5.6 squared. If I want to calculate the calculator to do that subtraction before it divides, then I have to hit equals to get my numerator. And then divide by, I've got to use parentheses to have all of that in the denominator. Divide by, in parentheses, -2 times 3.7 times 5.6, close parentheses. I'm getting about -1.23 as the value of this numeric expression. So what's going to happen when I hit inverse cosine? Can you tell me before I do it? Tell me anything you can think of that you know about the angle whose cosine is -1.23. What if that in itself was a problem on the test? What if I just said, evaluate inverse cosine of -1.23? What would the answer be? What do you know about all the values of cosine? All the x values on the unit circle? Are between
1 and -1?
Yeah. All the x's on the unit circle are between -1 and +1. There is no angle whose cosine or whose x value is -1.23. So if that was a whole problem on the test, what would you write down for inverse cosine of -1.23?
Undefined.
Yeah. And what does that mean about those 3 sticks that I gave you and told you put these 3 sticks together as a triangle?
No triangles.
Right. You can't make a triangle with those 3 sticks. Someday I'm actually going to bring sticks with me to show you why you can't put those 3 together as a triangle. It's because of the relationship between the length of this one and the length of the other 2. This one is about twice as long as that one. Let's say this one is 10 and this one is only half of that. This third side is too short to connect with the long side. And that's why you can't make a triangle with those 3 sticks. All right. Now, the only example I've done with a side triangle just turned out to be no solution. There's no triangle you can build with those 3 sticks. So I need to do an example that you can, that you do get a solution, but I thought for that we would just do one of the word problems. Actually, if we have time, I'd like to do 2 of them. We got about 10 minutes. The first one's easy. So let's look at number 20. To find the distance between 2 points A and B, a surveyor chooses a point C that's 420 yards from A and 540 yards from B. Now, if a surveyor is trying to find the distance from A to B, why doesn't he just measure the distance from A to B? Why would he have to choose some other point, C, if he's wanting the distance from A to B? This is not going to look to scale at all, but here's the distance he or she is trying to find. So the surveyor chooses a point C that is 420 yards from A and 540 yards from B. It certainly doesn't look on my picture like the side from B to the distance from B to C is more than the distance from A to C, but that doesn't matter. That's just because my pictures are not to scale. So why would a surveyor measure this distance and this distance instead of that distance? It's because there's a grizzly bear right here. My grizzly bear looks a whole lot like a person. Maybe it's a creek. There's some kind of obstacle between A and B so that the surveyor can't measure that directly. And that's why I'm going to say she chooses another point and gets these two measurements because something's blocking the way in finding this measurement. Now, these two things alone wouldn't be enough information to find X. So the other bit of information she has is angle ACB has a measure of 63 degrees, 10 minutes. The angle ACB is the angle at C, and that angle is known to be 63 degrees, 10 minutes. So actually, I think I may not finish this problem because it's not the other side example that I wanted to do. I just wanted you to be able to set up this one. If you, well, let's do one more step. Let's write down the equation. Do you have the information that you need to solve for X using the law of sines?
No.
No, you don't, because if you were going to, the only angle you have is the 60 degrees, 10 minutes, and to use the law of sines, you'd have to already know what X is. So we can't use the law of sines. We have to use the law of cosines. If we want cosine of this angle on the right, then on the left, we have to have the square of the side opposite it. And lucky for us, that's what we're looking for. We're looking for X. Instead of writing X squared equals and then taking the square root of both sides, I'm just going to say X equals the square root of the right-hand side of the law of cosines. And that's going to start with the sum of the squares of the other two sides minus twice the product of the other two sides. And I just didn't leave myself enough room. Cosine of the angle between them. So it's just a calculator problem from there. All right, last one. It's a little bit gnarly. Get harder to draw than the ones that we've done so far. It's number 24. Here's what it says. An airplane flies 165 miles from point A. Now, actually, the book has a picture drawn for me. I'm going to try not to copy that picture. I'm going to try to draw it on my own. So an airplane flies 160 miles from a point A. Eeny, meeny, miny, mo, here's some point A. And the plane flies in a direction of 130 degrees from point A. Well, let me tell you what that means. If you imagine A is the origin of a Cartesian plane, then 130 degrees, the direction 130 degrees is 130 degrees counterclockwise from the positive x-axis. So this would be 90 degrees, and another 40 degrees would be 130 degrees. Does that make sense? 130 degrees from the positive x-axis. And the plane goes 165 miles in that direction. And then it turns in a direction of 245 degrees from there. So it reaches some point B, and it turns 245 degrees from that point B. Again, you have to imagine B as being the origin of a Cartesian coordinate system and go 245 degrees from the positive x-axis. If I'm just looking at this Cartesian coordinate system right here, in what quadrant would there be a 245 degree angle?
Third.
Yeah, that's 180 and 65 more. So from here to here is 245 degrees. And he flies that direction for only 80 miles. The question is, how far is the plane from where it started? So if we call this C, then we're looking for the distance from C to A. All right, that's the best I can do with that picture. Now, I almost always end up with it not being big as I should have drawn it so that I could label some other things on it. What do I know? I'm looking for X, and to find X, I would have to know this angle opposite it right there. How can I find that angle? Well, there are a lot of things I could find here. If from this positive x-axis to where the plane turned is 240 degrees, what's this little angle right here that I've just marked?
Is that 65?
Yeah, I said a minute ago the plane went 180 degrees and then another 65. So that's a 65 degree angle right there. And let's see. I did this problem the other day just to make sure I didn't get stuck today. If we use a little tiny fact from geometry, a fact that you may have flushed right after you finish taking geometry, but there's a fact that comes in handy. One of the few facts of geometry that I use enough to actually remember it. It has to do with two parallel lines cut by a transversal. A transversal is a line that crosses the other two lines. Do those words ring any bells from geometry? Two parallel lines cut by a transversal? If I know that this is 130 degrees, that's this angle right here. In geometry, it's called opposite interior angles. The two interior angles formed by a transversal that cuts across two parallel lines. If this is 130 degrees, then this has to be 130 degrees. Opposite interior angles are equal. And what does this angle have to be if these two angles form a straight line?
50.
That little angle.
50.
Yeah. And so this one has to be 50. Now, that's a little inset from this picture. If this is 130, then here's my two parallel lines. Two parallel lines cut by this transversal. If that's 130, then that would have to be 130. What I just drew corresponds to this angle right there. So if that whole angle I just highlighted in blue is 130 and this little part is 65, then what does this part have to be? If this little part's 65, then that part has to be 65 for those two parts together to add up to the same 130 that this angle is. That's a pretty tough picture to draw. And because I never draw it big enough, I'm going to break it out right here and say we have just figured out that that is 65 degrees. And this is 165 miles. And this is 80 miles. And we're trying to find this distance right here. I don't think you have one in the homework that's quite that hard to draw, and I certainly wouldn't put the hardest problem in the homework on the test. I always shoot for a medium level of difficulty on the test, especially when we had to pull some fact from geometry that we haven't seen since the 9th grade or 10th grade. But now that we've got it drawn, you can see that the law of sines wouldn't apply here. I don't have enough information to use the law of sines, but I could use the law of cosines to find x. X would be the square root of the sum of the squares of the other two sides minus twice the product of the other two sides, cosine of the angle between them. The plane's about 155 miles from where it started. I said 155 and I wrote 150. I meant 150. All right, don't panic. Absolutely do not panic if you didn't understand that. That is significantly more difficult than what I would put on the test, but it's always good to see a problem that's harder than you would put on the test. That way, when you see the test, you go, oh, that isn't as bad as that number 24. For the homework, I have changed that to just 5 to 21 odd. I'm not sure what it says on your paper, but this is all I want you to do. So that's only 2 word problems, 19 and 21.
So, Ms. Miles,
Yes, ma'am.
you know the law of sine, we had to see if it can make 2 triangles.
Right.
Would we have to worry about that with cosine?
If you follow these 2 notes, if you're given 2 sides and the included angle, we found the, add this to your notes, find missing side first, then find the angle opposite the shortest side. By following that practice, if you find the angle opposite the shortest side, that's going to have to be an acute angle, and that's how you avoid the ambiguous case when this is the information you're given. The angle opposite the shortest side has to be an acute angle, a first quadrant angle, so you don't have to worry about, oh, but there's another angle in the second quadrant. So that's how you avoid the ambiguous case if you're given 2 sides and the included angle. When you're given 3 sides, if, let's see, side first by the law of cosines, and then find the angle opposite the shortest side by the law of sines. I need to just add this to the handout. When you're given 3 sides, if you find the largest angle first, then by the time you get to the law of sines, you cannot have more than one obtuse angle in a triangle. You can't have more than one angle that's greater than 90 degrees. So if you find it first, by the time you get to the law of sines to find the second angle, you've ruled out the possibility of, hey, it could be first quadrant or second quadrant. So following these 2 notes, which I need to write better on the handout, following those 2 notes is what avoids the ambiguous case, Kelsey. So no, you're not going to run into an ambiguous case if you do these 2 things.
All right.
All right, so just to make sure you know what we're going to do tomorrow. That's everything that we have to cover in pre-calculus this semester. Tomorrow, this is any questions you have from anywhere. You have a practice test that you print from Momentum, and you should do that. You need all the practice you should get. So go ahead and do the written practice test from Momentum. You can ask me any questions you have from that tomorrow. If you want to be a tiny bit lazy and not do the identities that are there first, if you don't want to do 1 through 5, that's That's your compensation for having to finish this class online. I'm not going to have one of these on the test because I can't put one of those online. But make sure, because you need a lot of practice at this, make sure you do the rest of this printed test, and you can ask me any questions from it tomorrow. You can also ask me any questions you have from the practice test in my math lab. Make sure if you have a question from my math lab, you write it down, because it'll give every one of you different numbers. So copy down the original problem so that I can see what numbers it gave you. And then the test is Thursday and we're through. Any other questions? All right. I appreciate y'all. It's just been a heck of a rough way to finish the semester. And I really, really do hope that everything is settled down and I get to see your shining faces in calculus this fall. Y'all have a good day.
Bye, Miss Miles.
Bye-bye.